Q from the 2015 BC exam. So we've got this chart that shows Joanna's velocity as she goes along a straight path. So they ask us to use the table to estimate V prime of 16. So V prime of 16 is going to be in between 12 and 20. So V of 20 minus V of 12 divided by 20 minus 12. So that's meters per minute. And that's 240 minus 200 over 8. So 40 divided by 8 is 5 meters per minute squared. They did not say the context of the problem. They actually didn't say units either, so technically you only needed to have the 5. All right, so using the correct units, they want to know the meaning of the integral from 0 to 40 times the absolute value of v of t, and then to approximate that using a right-Riemann sum. So the integral from 0 to 40 with an absolute value is the total distance. So if you guys recall, when there's no absolute value, that's displacement, because it kind of allows the area underneath the curve to like neutralize each other if you have a positive area and a negative area, if it's like moving back and forth. Once you slap that absolute value on there, then it just starts to add up those distances with all positive values, and so you can see the total distance you traveled, even if you went back and forth. So this value is the total distance traveled from time t equals 0 to t equals 40. Okay, so we're going to say the integral from 0 to 40 v of t dt is, and then we're going to go ahead and find all those areas, and they wanted us to do a right-Riemann sum. So the width of the first one is 12, height of 200, then 8, height of 240, then 4, height of positive 220. This is where you have to be careful. This is the easy place to mess up. So this is where that absolute value comes into play. Basically, if you look at her velocity, it's like, if we think of this as like the particle that's on the x-axis, she's moving to the right, she's moving to the right, she moved to the left, she moved to the right again. So if we're doing displacement, then we can add all those up with those signs. We can just see where she's at on the number line. But if we want to add that total distance, then we want to have the positives of all of these so that we don't neutralize some of the distance she's traveled by having that negative in there. So you need that positive 220. And then width of 16, height of 150. You could probably leave it like that. I went ahead and did all the math. So I got 2400, 1920, 880, 2400, and then altogether I got 7600. I did do lots of adding carefully off to the side to do that. Okay, part C says Bob is riding his bicycle on the same path, and there's his velocity. They want his acceleration when t equals 5. So for this one, we just have to say, okay, if b of t is t to the third minus 6t squared plus 300, then the derivative of that, which would be his acceleration, is 3t squared minus 12t plus 0. And then we can go ahead and plug in 5. So you can leave it like that, or you can say 3 times 25 is 75 minus 60. So it looks like his acceleration is 15. Minutes, meters per minute, so it'd be meters per minute squared. They did not say you had to have the units, so you can probably leave those out. All right, part D says, based on the model from C, find his average velocity. So whenever they say average velocity, that's average value of velocity. So that's that integral equation. So we're going to say that's going to be 1 over 10 minus 0. And then integral from 0 to 10 of b of t. And actually, let me write it because we're going to have to figure it out. Of t to the third minus 6t squared plus 300 dt. So we've got 1/10, and then we've got 1/4 t to the fourth minus 2t to the third plus 300t evaluated from 0 to 10. You cannot stop there. You have to plug the numbers in if you're going to leave it unsimplified. So from here, I said, okay, I've got 1/10, and then that's 1/4 times 10 to the 4 minus 2 times 10 to the third plus 300 times 10 minus 0, right? Because when you plug 0 in, you don't get anything. And then you should be able to leave it there. I went ahead and continued it. Minus, that's 1,000 times 2 plus 3,000. So 10,000 divided by 4. Half of 10,000 is 5,000. Half of that is 2,500. So we've got 2,500 plus 1,000. So that's 1/10 of 3,500. So that's 350.